Hello and welcome to the first video of our fantastic unit. It's really a short one about vectors, and just a warning and alert. You're going to need a calculator. I'm not sure about for this lesson. Calculator wouldn't hurt, but definitely for later on. 100% you'll need a protractor and you'll need a ruler. In case you forget what a protractor looks like, most of them look like a semicircle, and it's used to measure angles. You can probably borrow one from me, or you can buy one somewhere. So you should have those once you are ready to start this video. So if you need to hit pause and come back, that's fine. I won't notice, and then we'll be good to start. So let's take a look at this little picture here. This funny cartoon. The guy's thinking about a bag of gold. First of all, it's always fun to think about gold. So let's say we got a bag of gold, and let's do something we've done before. Let's talk about the forces acting on this bag of gold. So I'm going to make the bag of gold a box of gold because I can't draw. So let's think about what are the forces acting on that bag of gold. Well, there'll be a force downwards. There'll be a force of gravity downwards. And there'll be the table that I placed the bag of gold on upwards, so that would be that normal force upwards. And if I was to think about how much gold do I have? How much gold do I have? Really, I would not be thinking about forces at all. Really, I would be talking about the mass of the gold, right? So, I don't know. Let's say that the mass is equal to 1 kilogram. That's a heck of a lot of mass. For gold, anyways, it is. So I got 1 kilogram of mass. So if you recall, then I would end up getting 10 newtons for each kilogram. So I would actually have a 10 Newton force downwards and a 10. I'm assuming it's not accelerating and all that's at rest. So that's something it would look like. So I want to point out the difference between this idea about mass is 1 kilogram. Could I talk about a direction for that mass? Does it have a 1 kilogram up, 1 kilogram down? No, that doesn't really make sense, does it? The forces, however, definitely have direction, and we indicate that with arrows. So I just want to talk about then, whenever we do a measurement, measurements are going to go into two different categories. They're either going to be scalars or they're going to be vectors. So one example of a scalar then is when we're talking about mass. And when we're talking about vectors, they have direction. Forces are going to be in that one. So that would be for our example. Let's talk a little bit about what is in when we do a measurement. So this one had a number and a unit, right? So when we're talking about a scalar, you got to have a number plus a unit. Now I can talk about that all at once. I can say that has a certain magnitude. Like, magnitude really means size. How much? Well, if I'm going to answer the question of how much gold was there, I'd say 1 kilogram. Why it has to have a number and a unit? Because if I was to answer, say, 1,000 grams, that's really the same amount of magnitude. So I have to include a unit to make sense of what that number means. So if I just said I had 1 of gold, you'd say, well, 1 what? 1 kilogram, right? So that's really the magnitude. So a scalar only has magnitude. When we have a vector here, we have a number and a unit, but we also have a direction. So I could say 10 newtons down. That down information was really in my arrow here, the fact that it went downwards. But if I say, can you fully describe the force of gravity? You'd have to say 10 newtons downwards. So over here, when we talk about vectors, I only say that this has a magnitude. That's the 10 newtons part. And it has direction. So just to recap here, scalars, just magnitude. Vectors, magnitude and direction. They got them both. I think we can probably come up with a few other examples for scalars and vectors. If I was to say, what's the temperature outside? Maybe it's 18 degrees Celsius. Is that a scalar or a vector? Can we have 18 degrees up or down or left or right? Not really. So a temperature would be another example of a scalar. If I was saying how fast you're driving, that would be your speed, and that would just be how fast you're going. But if I was to say how fast and what direction, now we're talking about velocity. So we have some that are very similar. Speed and velocity are very similar, except speed is the scalar version and velocity is the vector version. Okay. What about and similarly distance? If I say I walked 5 kilometers today, that would probably be the distance. But if I said, hey, I need to get 5 kilometers from here, that would be the difference between where you started and where you ended, and that would be your displacement. Okay, so let's talk about scale diagrams. We've done lots of forces and things like that, and we've used arrows before, just like in my previous example. But we're gonna get a little bit. We're gonna zoom in on this idea. In the arrow there, we can say one side is the tail, the other side's the head, and we can do a diagram of vectors with arrows all the time. When we have direction, often we're going to be using north, south, east, west. Sometimes this might get switched around a little bit, but generally we're going to indicate what direction things are with this north, south, east, west indicator. Let's try our example. It says Kelson went for a walk. He ended up at a location 120 meters away from his starting point. So we don't know the path he took. We know the starting point and the ending point had a difference of 120 meters. And he ended up at a direction 30 degrees north of west. Let's talk about that 30 degrees north of west. So looking over here, 30 degrees north of west. So first you say, I'm going to point myself west. So I'm going to point myself this way, west. And then I want to rotate 30 degrees north of that. So this would really, if I rotate 30 degrees north of west, that's what that looks like, okay? So let's say I said 10 degrees south of east. So here's east, here's south. It would be 10 degrees south of it. So I would be going 10 degrees south of east. That's what that would look like, okay? 30 degrees. So that's sort of an indication of what the direction will look like. Okay, so we're going to do a scale diagram, and so that we're going to be very careful about the length of our arrow is going to give us a rather precise indication of that 120 meters. So the first thing we want when we do a scale diagram is to write the word scale, and we need to say just like in a map, 1 centimeter might equal a kilometer on a map. On our scale diagram, we're going to say 1 centimeter equals something, and we have to figure this out. So if I realize it's going to be 120 meters, I need to fit something. I'm going to choose a scale so that my diagram is large but will fit on the page. So in fact, looking at my arrow, I'm realizing here that it's going to go, up and to the left. So if I started way down over here, so let's say this is where my start is. If I use my ruler, so get out your ruler now. What's the largest? What's the maximum amount of space that maybe I'll just even move over a little bit more, because if I move over like way over like this, and what's the largest I could get if I'm going with that direction? I think I could probably do 12 centimeters. So if I say 1 centimeter equals 10 meters in this case, okay? Now, I'm doing the screencast, so I can't, normally I get my ruler out and stuff. And when I'm going to do my direction, first I would use my ruler and just kind of do a little east-west line and a north-south line. I would kind of do like that, but do it nicely with your rulers and make sure that these are exactly, horizontal and vertical. So I'm just going to label this direction as north and this direction here is west. Now imagine me now getting out my protractor. So I would get my protractor and, I don't know, maybe kind of put it right over top of here. So here's a drawing of my protractor, right? And there's ticks on here, and I want 30 degrees. So maybe that's 30 degrees. And then I get my ruler out and I draw a nice line. Okay, I'm just freehanding it here. It might not work that well, so I'm going to draw my line. I'm trying to draw my line all the way out here. Oh, boy, okay. Let's just pretend I did a good job on that, and that's a nice straight ruler. You're going to do better at home. And I draw that. And in real life, that would be a 12 centimeter line, right? 12 centimeters using your ruler. But when I label my diagram, I don't want to label it 12 centimeters. I want to label it 120 meters because it's a scale diagram, and I want to say that represents 120 meters. I hope that makes sense to you. And that's what my scale diagram would look like. So again, use a ruler. And being exact is kind of important when we do these scale diagrams. I want to talk about direction just a little bit more. So I already talked about what 30 degrees north of west looks like. It means like point yourself west and then rotate 30 degrees there. 155 degrees CCW, counter clockwise, that's the CCW, from east. So if you've done this already in pre-cal, this is kind of like a counterclockwise from the x-axis. So if this here is 0 degrees, okay, and then this would be 90 degrees, this would be 180 degrees, and down here would be 270 degrees. So here if I went 150 degrees counterclockwise from east, it's the exact same angle where that's 150 degrees. Okay, so again, if you did 180 minus 150, you'd put a 30 in there. It's the same direction. This one's a bit obscure, and just in case you encounter it from looking online or other textbooks and things like that, this is point yourself west, then rotate 30 degrees towards north. So in other words, if this is west, look west first, and then go 30 degrees towards the north. So all these three are exactly the same. They're just different ways of talking about it. Okay, your turn. All right, so I want you to find the direction and the magnitude of the vector. You know what? I'm going to do the your turn, and I'm going to do this example, and then I'm going to get you to do the 3 practice ones underneath. So for this one, here is a scale diagram, and it says a scale is 1 centimeter times 2 meters. So the first thing would be is to get your ruler out, and can you measure the length of that arrow? And I apologize, it's kind of a fuzzy, it's thick and it's not so easy to do. So take a look and measure it. When I measure it, I get approximately 1.8 centimeters. Now, that's not the magnitude of the vector, that is the length of that arrow on the page. So to figure out what the actual vector is supposed to be, I'm going to multiply by my scale. My scale is 1 centimeter is the same as 2 newtons. So there's 2 different conversion fractions I can make with that. I can go like this, or I could say 2 newtons over 1 centimeter. Now which one do I want to multiply that by? Because I have to choose one of those two. I'm going to choose the one that has the centimeters in the denominator, like this, 2 newtons over 1 centimeter, because now my centimeters will cancel out, and then I will get an answer of, well, 1.8 times 2 is what, 3.6? Let's erase this business here, 3.6 newtons. Okay, so the magnitude of this vector is 3.6 newtons. How big is it? It's a 3.6 newton force vector in this case, because newtons is a measurement of force. Now, what's the counterclockwise direction? So if I get out my protractor, and if I measure off of this line, when I get my protractor and I measure, this part here looks to me like about 70 degrees. Okay, or if you were to measure the smaller one here, this one over here looks to me about like 20 degrees when I get my protractor out. So what I want to do is figure out what is the counterclockwise from east. So if I'm going like this, I'm going to hit 90, I'm going to hit 180, and then I have to do 70 more. So really it's 180 degrees plus 70 degrees, which should add up to 250 degrees. So my right answer would be 250 degrees. Alternatively, I guess you could go and say, okay, this was like, this one's down to 70, and I could go back 20, right, and still get 250 degrees, but it's the same answer in either way. Okay, I'd like you to hit pause right now and then try these three, it's going to be a little bit hard, and I'm not too worried about getting the exact answer. I just wanted you to get in the right ballpark. So don't sweat over, is this like 14 or 15 or 13 degrees? Just to the nearest, 5 degrees is okay. And then hit pause now, and then come back and I'll show you the answers I got. Oh yeah, I guess I should say it's just the direction we want. Don't worry about the magnitude. Okay, so the values I got for those were, about 25, 26 degrees for the first one, 105 degrees for the second one, and about 340, maybe even 339 for that last one. Okay, so here is our number 2. Oh, there's too many here to do. How about I will do a couple for you. I'll do A, and then maybe and I, and then for practice, I'm going to get you to try. I think G is a nice one, and H is a nice one. So I'll do A and I right now, and then you can try G and H, then I'll show you the answers. It says, determine the direction of the resultant displacement for a person who walks from A to C. So I'm really only interested, again, just in the direction. So the first thing I would do is say, okay, from A to C, I gotta keep track of what is the right direction. So if I just draw a line from A to C, and you know what? If I use a physical ruler on the, I'll try this physical ruler on the screen, maybe it'll help me out. So if I draw this arrow here, hey, that's not bad. Now, oh, sorry about that. There we go. Now, which direction is it going? Like, which way is the arrow going? From A to C, well, that means it's going this way. So I'll put an arrow in there. When you put your protractor down, here's a little bit of a pro tip. I should have mentioned this earlier. Darn it, I should have mentioned a long time ago. It's that really to do with a light pencil to make this longer, it's a lot easier with the protractor. So sorry if you've been sweating that detail already. So you might want to go and just extend it lightly with your pencil so that it just makes it a little bit easier to use with your protractor. And then you're going to measure this with your protractor. So I would probably take my protractor and physically plop it down so it kind of looks like this, and then I would measure that part here. That number of degrees there, when I read it, I think it's I'm not sure, I'll have to check. Okay, I just checked, and I think it's about 68 degrees according to my measurement. So now when I figure out this distance here, I would say, well, that would be the same thing as 360, because 360 is a full circle, minus 68. So I think I would get 292 degrees. For letter I, it's a little tricky. I says, here we're going to go from I to K to B. So we're starting here, then we're going to K, then we're going to B. I'm just going to erase all my mess here. But remember, we're talking about displacement, so it doesn't matter about your path. It just matters about where you started and where you ended. So really, we're just looking at that arrow right there. So when I do that measurement there, I end up getting a 12 degrees here. I'm getting very messy. So my direction is 192 degrees. So I would like you to try G and H. Now hit pause, give it a shot, and I'll show you my answers. Alright, the answers I got for G, which was going from E to K, was 16 degrees, and the answer that I got for H, which is from J to F, was 162 degrees. Just before you go and try out the MOP, the Minds on Physics, I'm just going to mention that part of the questions involved this wheel where you have to drag. It's kind of like a big circular protractor. And I was going to say, okay, if this is 0 degrees and this is 90 degrees, halfway at this point here would be 45 degrees. And you can see there's 3 divisions. So they actually go by 15 degrees. So that's part of the effort. You got to drag this around to measure the angle. I think you'll get used to it. And then each tick on there, it's not labeled, goes by 15 degrees. Okay, so now that you're done this, I want you to go to the Minds on Physics and do the mechanics, and then choose vectors and projectiles, and then the first sublevel. Thank you, and I'll see you in class.